In this video, we will learn how to use the properties of logarithm and the change of base formula. If the bases are the same, we have the following properties of logarithm. First, we have log to the base a of x times y is equal to log to the base a of x plus log to the base a of y. So if two numbers or two expressions are multiplied in the argument, we can expand this single term into two terms in which log to the base a of x and log to the same base a of y are added. Or if we are given the sum of two logs to the same base, we can combine these two terms into this single term, log to the base a of x times y. Next, we have log to the base a of x divided by y is equal to log to the base a of x minus log to the base a of y. So if two numbers or two expressions are divided in the argument, we can expand this single term into these two terms, okay, in which log to the base x and log to the same base a of y are subtracted. Or if we are given the difference of two logs to the same base, we can combine these two terms into this single term, log to the base a of x divided by y. Next, log to the base a of x to the n is equal to n times log to the base a of x. So we can simplify this expression on the left side by bringing down the exponent of the argument before the logarithm. Okay, so in other words, we have to multiply the exponent n of the argument, okay, multiply it by the rest of the expression. Now let's consider some examples of simplifying logarithmic expressions using the properties of logarithm. First, what is the value of log to the base 2 of 8 times 32? Okay, so we have here 8 and 32 multiplied in the arguments. Therefore, we can expand the single term into two terms in which we can separate 8 and 32. But we have to use the same base. Now, since these numbers are multiplied, we have to use plus. Okay, so we can rewrite this expression into log to the base 2, same base 2, of the first argument, so that's 8, plus log to the base 2 of 32. Next, since we are getting the log to the base 2, we have to express 8 and 32 as the base 2 raised to some exponents. Okay, since 2 times 2, 4 times 2 is 8. 8 is 2 cubed. Okay, 32 is 2 to the exponent 5. So let's evaluate these logarithms. Okay, to what exponent do we raise 2 to get 2 cubed? We have the exponent 3. To what exponent do we raise 2 to get 2 to the 5? We have the exponent 5. 3 plus 5 is equal to 8. Next, let's say we have log to the base 4 of 4 divided by 64. Okay, since in the argument we have a division of 4 and 64, we can expand this single term into two terms. So we can separate 4 and 64, but we have to use the same base 4. And since we are given a division in the argument, we have to use the operation minus. Okay, so we can rewrite or expand this expression into log to the base 4, same base 4, of first, okay, the numerator, that is 4, then minus log to the same base 4 of the denominator, 64. Since we are getting the log to the base 4, we have to express 4 and 64 as the base 4 raised to some exponents. Okay, so to what exponent? 4. 4 is 4 to the 1, exponent 1. 64 is 4 times 4 is 16 times 4, that is 64. Therefore, 64 is 4 cubed. Let's evaluate the logarithms. To what exponent do we raise the base 4? To get 4 to the 1, that's 1, the exponent 1. Next, to what exponent do we raise 4, the base 4? To get 4 cubed, we have the exponent 3. Let's simplify. Y minus 3, that is equal to negative 2. Next problem. Let's say we have log to the base 3 of 27 squared divided by 81. Okay, so since in the argument we have a division, we can expand this single term into two terms. So we can separate 27 squared and 81, but we have to use the same base 3. And since we have here division in the argument, we have to use the minus operation or the difference. Okay, so let's rewrite this single expression into two terms. So we have log to the base 3 of the numerator 27 squared minus log to the same base 3 of the denominator 81. To simplify the first term, we can use the third property of logarithm, okay, in which we can bring down the exponent 2 of the argument 27 before the logarithm. So this term becomes 2 times the rest of the expression, or we have 2 times log to the base 3 of 27. But since we are getting log to the base 3, we have to express 27 and 81 as the base 3 raised to some exponents. Okay, so 27, 3 times 3 is 9 times 3, that is 27. So 27 is 3 cubed. Remember 2 is already this one. Okay, so how about 81? 3 times 3 is 9 times 3, 27, times another 3, that is 81. Therefore, 81 is 3 to the 4. To simplify, let's evaluate the logarithm. So we copy the number 2. Okay, to what exponent do we raise 3 to get 3 cubed? We have the exponent 3. To what exponent do we raise the base 3 to get 3 to the 4? We have the exponent 4. Let's simplify the this expression. 2 times 3 is 6 minus 4, that is 2. Next, given that log to the base 4 of b is equal to 3. So we are given this value. Again, log to the base 4 of b, the value of this expression is 3. The question is, what is the value of log to the base 4 of 16b to the 7? Okay, so in this logarithm or logarithmic expression, we have 16 and b to the 7 multiplied in the argument. So we can expand this single term into two terms, okay, in which we can separate 16 and b to the 7, but we have to use the base 4, the same base 4. And since 16 and b to the 7 are multiplied, we have the operation plus. Okay, so let's rewrite this into two terms. We have log to the base 4 of the first argument, 16, plus, okay, log to the same base 4 of the second argument, b to the 7. Since we are getting getting the log to the base 4, we have to express 16 as the base 4 raised to some exponents. Okay, and we know that 4 times 4 is already 16, therefore 16 is 4 squared. Next, how do we simplify the second term? Okay, we can use the third property of logarithm to bring down the exponent 7 of the argument, okay, before the logarithm. In other words, we have to multiply 7 by the rest of the expression, or that is times log to the base 4 of b. Okay, to simplify the first term, we have to get the exponent. So to what exponent do we raise the base 4 to get 4 squared? We have the exponent 2. Okay? Okay, how about the second term? We have 7, so let's copy 7. Then we have the expression log to the base 4 of b. Okay, now remember that we are given the value of log to the base 4 of b, and that is equal to 3. So let's substitute 3 into log to the base 4 of b. So we have 7 times 3. To simplify, let's multiply 7 and 3. That's 21 plus 2. We get 23. Lastly, what is the value of x in the logarithmic expression log to the base 3 of 27 raised to the exponent 2x minus 1 is equal to 3? To solve for x, first we have to simplify the left side of the equation. To do that, we can use the third property of logarithm, okay, in order to bring down the exponent 2x minus 1. So we can bring down 2x minus 1, and we have to multiply it by the rest of the expression. So quantity 2x minus 1 times log to the base 3 of 27 is equal to 3. Now, since we are getting log to the base 3, we have to express 27 as the base 3 raised to some exponent. Okay, 3 times 3 is 9, times 3 is equal to 27. Therefore, 27 is 3 cubed. Let's evaluate log to the base 3 of 3 cubed. So, to what exponent do we raise 3, the base 3? To get 3 cubed, we have the exponent 3. So, that is 3. To simplify this expression, okay, we can divide both sides of the equation by 3 since they both contain 3. Okay, if we do that, we are left with 2x minus 1 on the left side, and on the right side, or rather the right side becomes 1. That is 3 divided by 3. To solve for x, let's isolate the x term on the left side. So we have to transpose negative 1 to the right side. So it becomes, on the right side we have 1. Okay, and this becomes plus 1. Therefore, that is 2. To simplify this equation further, let's divide both sides of the equation by 2. So on the left side, we get 2x. And on the right side, we have 2 divided by 2. That is 1. This time, let's discuss the change of base formula. The change of base formula is used to change the original base to a more convenient one. Okay, so this is the change of base formula. We have log to the base b of x, that is equal to log to the base a of x, divided by log to the base a of b. So notice that on the left side, okay, which is the original expression, we have log to the base b. But if we cannot easily use b as the base to get a base for the argument x, we can change this base b to any number, any base. So let's say that new base is base a. Okay, so to change this base b into a, we have to divide log to the new base a of the original argument x, and divide that by log to the same base a of the original base b. So the question is, how do we find the new base a? Okay, so according to this one, okay, we want a more convenient base. Okay, so the new base should be a common base of the original argument and the original base. Again, it is a common base of the original argument and the original base. For example, can we easily get log to the base 4 of 8? Let's see, 4 times 4 is 16. Therefore, it is not easy to get log to the base 4 of 8. Okay, but do the numbers 4 and 8 have a common base? Yes, that is 2. Okay, so we can rewrite this into log to the base 2 of the original argument 8 divided by log to the same base 2 of the original base 4. Okay, so since we are getting log to the base 2, we have to express 8 and 4 as the base 2 raised to some exponents. Okay, so we have, okay, for 8, 2 times 2 is 4 times 2 is 8. Therefore, 8 is 2 cubed. And we know that 4 is 2 squared. Okay, so let's evaluate each logarithm. So to what exponent do we raise 2 to get 2 cubed? We have the exponent 3. To what exponent do we raise the base 2 to get 2 squared? We have the exponent 2. Therefore, log to the base 4 of 8 is 3 halves. Now let's simplify some logarithmic expressions using the change of base formula. First, let's say we have log to the base 9 of 27. Okay, first question, can we get 27 using the base 9? Let's see. 9 times 9 is already 81, so no. Okay, therefore we have to change the base 9. Okay, so now the question is, to what base should we change the base 9? Okay, let's consider the argument 27 and the base 9. Okay, what is the common base of the two numbers? That would be 3, right? Okay, so let's rewrite this into this fraction. So we have log to the base 3 of the original argument 27 divided by log to the same base 3, the new base, okay, of the original base 9. Okay, so next, since we are getting the log to the base 3, we have to express 27 and 9 as the base 3 raised to some exponent. Okay, so let's consider 27. Okay, 3 times 3 is 9 times 3 is 27. So 27 is 3 cubed. And we know that 9 is 3 squared. Let's evaluate each logarithm. So to what exponent do we raise 3 to get 3 cubed? We have the exponent 3. Next, to what exponent do we raise the base 3 to get 3 squared? We have the exponent 2. Lastly, we have log to the base 4 of 32. Okay, can we get 32 using the base 4? Let's see. 4 times 4, that is 16, times 4, that is already 64. Therefore, we cannot get 32 using the base 4. So we have to change the base 4. If we consider the original argument 32 and the original base 4, okay, the common base is 2. Okay, so let's rewrite this into a fraction. We have log to the new base 2 of the original argument 32 divided by log to the new base 2 of the original base 4. Now, since we are getting log to the base 2, we have to express 32 and 4 as the base 2 raised to some exponents. Okay, 2 times 2, 4 times 2, 8 times 2, 16 times 2, that is 32. Therefore, 32 is 2 to the 5. And we know that 4 is 2 squared. Okay, let's evaluate each logarithm. So, to what exponent do we raise the base 2? To get 2 to the 5, we have the exponent 5. To what exponent do we raise the base 2? To get 2 squared, that is the exponent 2. So, the answer is 5 halves. If you have any question, please leave a comment.